So good morning, everyone. Just give us a minute more. We will just allow more people to join in. Also, I will wait for my team to give me a confirmation from the social media side that we are live. Okay, we have the confirmation that we are live and we can just get started. So, hello and good afternoon to you all. My name is Vishal and I welcome you to the session today on the Ceasefire webinar series. So viewers, in this series, what we do is we bring on focus a particular fire safety technology from Ceasefire and then share insights on all aspects around that technology. Being the leader in this segment, we are obviously very passionate about all that we do, and certain fire safety technologies we've developed in a way that they address certain unique fire risks and applications. So at Ceasefire, we've certainly moved beyond the scope of conventional fire extinguishers to create some highly specialized fire systems which are designed and developed with extensive research and groundwork, to be able to meet a specific demand, to be able to solve a unique fire risk, to be able to solve a unique problem that we face in the area of firefighting. So the technology that we have on discussion today, viewers, is a flagship Ceasefire technology from the in-panel fire suppression segment. We call it the Ceasefire Quick Response System, or the CQRS. But before we get into the specifics of the session today, I'd like to thank each one of you for sparing time and joining us in the session today. Thank you so much indeed. So today, whether you are a Ceasefire customer, somebody who is wanting to invest into a in-panel fire suppression solution, whether you are a Ceasefire trade partner or whether you are a Ceasefire employee, I will try my best to make the session useful for you in the next 30 minutes or so. So we will do that bit from our side. So to do a little bit of context setting before we get started with the session today, the technology that we are going to be talking about is a specialized system that is developed and designed to address the need to fireproof electrical panels. So I'm 100% sure that all of you would agree, and nobody will deny the fact that in the modern times that we live in today, electricity is really the lifeline. So today, whether you are sitting in your home, in your office, in your factory, or you just opened the restaurant for the day, your school, your hospitals, your mall, everywhere, electricity is making life move. And if I was to tell you that wherever you are sitting, if there is a power outage for 2 seconds, I guarantee it will lead to an anxiety attack at your end, because in the absence of electricity, everything grinds to a halt. Now, this electricity that is making everything possible for us is not reaching your premises straight from the distribution lines. So wherever you are, there'll be an electrical panel from where the electricity is getting distributed to your premises. And that spot, that panel, is most vulnerable at times to catching fire. We've often seen in the past that many fatal fires have originated from these vulnerable spots. And that is where at Ceasefire we developed a specific solution to safeguard electrical panels. And that's what we have on the table for discussion today, which is called the Ceasefire Quick Response System. So why, to begin with, why do we think that fighting fires in electrical panels is such a big challenge? It is difficult for two prime reasons. One, any premises will not generally have just one panel. There are so many there, and you really would struggle to find out which panel is on fire, which needs attention immediately. And number two, and for very obvious reasons, the very sight of an electrical panel on fire due to electrical short circuit is a horrific sight, and that's something that you would want to be 100 feet away from and not go near, because it's really scary to see an electrical panel on fire and to think about how to douse fire manually there is not an ordinary person's cup of tea, and that's for sure. And that's where this new system, this technology that we've developed comes into play, which gives you automatic protection, in electrical panels at places where it matters. So before we get on to the specifics of how the system works and what it does and what the application areas beyond the electrical panels are, I think I will just broadly explain you the range that we have, and the kind of system that we do, and how the system works. At the heart of the system primarily is a heat sensing tube. So this one, viewers, is a polyamide tube, which does the job as far as this system is concerned. So on one side, you have a direct version of the system. On the other side, you have an indirect version of the system. Very simply put, in the direct version of the system, the heat sensing tube, this tube is doing the detection as well as the extinguishing agent is getting expelled from the same place. So if you have, a panel which is compartmentalized, then this is what you would need, because it will get activated at the spot where the fire needs to be killed, right? That's the direct part. In the indirect system, this tube will only do the detection bit. It will detect where the fire happens, but the activation, the extinguishing agent will be expelled through a separate discharge line. That's meant for places which is non-compartmentalized, where you need to really flood in a lot of agent and achieve that flooding effect to quell fire. So that primarily is the bifurcation, the two types of systems that we have. And within these two systems, you have, a low pressure technology under which you have specialized agents like HC227EA, fluoroketone. You have high pressure where you have CO2. We also do this in powder. We're now also introducing the CQRS range in the foam agent. So what happens is that these systems are customized for the panels or the space that needs protection at your premises. And that's why you have a whole variety and a whole range of systems at the back end, so as to be able to meet the need of what is actually required and what will actually go best in your kind of a place. So whether it is a direct application, whether it is an indirect application, what agent, it all depends on what the risk of fire is and how the designers at Ceasefire would want to configure a system for you. So I think I'll stop at that point and pull up a small video for you, which will just give you an overview of what the technology is all about. We also have our subject matter expert today, which I will call in a minute. Pranav is with us to take up any questions that you have. But before that, let's look into this video. I also have a short live demonstration video lined up for this session today. And then it will be very interesting to take up all sorts of questions that you may have around this technology. So give me a minute before I pull up, a short video for you.
Electrical panels are an important feature in almost all kinds of modern spaces, be it residential premises or large workspaces such as offices, factories, hospitals, malls, hotels. Electrical panels constitute an important part of the essential infrastructure. These panels are often also the areas that are most vulnerable to catching fire due to short circuits or overloading. Many times, the culprits behind large fatal fires in modern buildings are these electrical panels where fires typically originate. On the other hand, there are certain specialized enclosed spaces like wind turbines, mobile towers, switching centers, CNC machines, and other enclosed machinery which also face a high risk of fire, causing a serious threat to their respective environments. An effective approach to fireproof large premises is to safeguard these small vulnerable areas first. Addressing this unique need, at Ceasefire, we've developed a revolutionary fire suppression technology called the Ceasefire Quick Response System, CQRS, an automatic system designed to protect any enclosed space against fire, 24/7. What makes the CQRS system truly outstanding is its highly advanced detection technology that is based on pneumatic heat-sensing tube-based detection. One end of this pressurized tube is connected to an extinguishing agent container via a specialized pneumatic valve, and the rest is snaked inside the cabinet that needs protection, covering all the vulnerable points inside. A dedicated pressure gauge indicates the pressure in the heat-sensing tube, and a pressure gauge in the agent container indicates the pressure inside the agent container. The minute the pneumatic heat-sensing tube detects fire, it bursts open as soon as the temperature reaches between 150 to 180 degrees Celsius to form a miniature nozzle. The tube is pressurized and connected to a specialized valve. As soon as the fire is detected and the tube gets burst, it drops the pressure in the tube and trigger opens the valve to release the extinguishing agent. The CQRS systems come in two prime variants, one being the direct, the other being the indirect system. Direct systems are generally meant for spaces that are compartmentalized, whereas the indirect systems are designed for non-compartmentalized cabinets. In case of the direct system, the pneumatic heat-sensing tube works both as a detection sensor and also acts as the discharge line for the extinguishing agent, whereas in the indirect system, the pneumatic heat-sensing tube acts as the detection element, and once the fire is detected, the extinguishing agent is discharged from a separate discharge line. Taking the intelligence quotient of the system to a whole new level is the state-of-the-art response panel of the system. The response panel, being capable of monitoring up to 4-cylinder systems, gives a ready health check of the system to the user. Fitted with large LED screen, one can monitor key aspects of the system, such as pressure status of the heat-sensing tube, open-close status of the indirect valve, battery status, and power supply status to the system. Giving alarm through the attached siren strobe in a fire event, the response panel also enables users to connect the system to other third-party devices in the premises. Both the direct and indirect CQRS systems come in high-pressure and low-pressure variants with a range of extinguishing agent options to choose from, such as fluoroketone, FK, HFC 227EA, CO2,
HFC 236FA.
ABC dry powder, and also FFF foam-based solution for enclosed spaces with Class B fire risk. The system in its direct low-pressure variant in HFC 227EA and fluoroketone agent is an LPCB certified system that is certified under the LPS 1666 standard for both natural and forced airflow cabinets. Being a self-actuating automatic system, the CQRS brings in 24/7 protection for any kind of enclosed space that needs to be fireproofed in the premises. The Ceasefire Quick Response System protects what is most crucial.
So that was a short video on the product. What I will do now is I will call upon our subject matter expert Pranav into the picture, and then Pranav, if you can join us. Thank you. Thank you for coming.
Good afternoon, everybody.
So for the benefit, I think I'll just move the camera slightly this way. So Pranav, for the benefit of the starters, because today we might have people who have newly joined the organization or have newly become our trade partners, so I will begin from the very step one, because I think we gave a broad overview, but for people who want to know the technology in close proximity, how does the system get into action? When we say the HST tube does the detection, can you, for the beginners, explain the very mechanism that triggers the system into action with this?
Now, see, if to add on what Vishal has already told you, okay, the heat sensing tube has been designed specially to detect your fire, to actuate the system in indirect system. And the most important part of this is to have it as close to the source of the fire to get the quickest response. That's why we call it the Ceasefire Quick Response System. Now, to do that, we have actually gone with the LPS 166 standard in the direct low pressure system for which it exists. But we have extended the same kind of principles into other systems which are not covered under this standard, because we found that the LPS 166 has formulated such a standard that indicates for each and every person who has developed a system like that to have it tested to how effective it is going to be at what distance from the source of the fire.
Sure.
So they've tested it for
yes,
everybody.
absolutely. So Pranay, what we'll do is we'll come to the certification part and the whole design part of it in step 2 for the benefit of starters. Because I don't know how much will they be able to absorb while we talk and with this short video that we played. If you just explain the very mechanism, how a direct system and an indirect system kicks into action, as a start point.
So, Vishal, if you will start with the direct system,
Yeah, sure.
simplest to understand.
Yes.
Okay, so let's imagine this is a tube connected to the head of your direct pressure valve.
So this is a direct
Okay,
container that we have here, which has a port to put the pressurized tube. The tube
gets connected over here.
and the tube has dry nitrogen inside.
Not at present. Okay.
No, not as present, but in the system.
When we install the system, we're commissioning it, then we put dry nitrogen over here, which is going to be to equivalent pressure as there is in the agent cylinder.
On the other side, you have
On the other side, you can also extend the tube, or you can just dead plug it on this end if you're not using it. And then you have something called the integrated ball valve. This integrated ball valve, to all, it seems as just a simple ball valve. But what we've done over here, we've taken this ball valve and integrated it into the main valve body. Now, once we've done that, what we've done is that we have decreased the number of ports, and we have also kept the body inside the main valve body to decrease the number of joints. That in turn, which means that your system is going to be stable for a very long period of time. Similarly, with the tube, what we've done is we've kept it as a multi-layer tube. So the permeability of the tube also maintains the pressure for a long period of time. You would not like, if I have to take a very simple analogy, that if you have a very nice tire and you have to go every day to a pump to increase the pressure to its required pressure in the environment, it becomes a problem. Here,
so we were
so here the system remains stable for a very long period of time. Now the only thing that's going to happen is, as soon as I open the ball valve over here, my cylinder pressure and my tube pressure now comes at equilibrium, or there's a straight passage now. So as soon as the tube ruptures, the nitrogen ahead of the valve, goes out of that small rupture, and the contents under pressure are going to be expelled out by the same propellant, and it will come out through that rupture itself. So this kind of operation is called the direct operation.
At what point does the tube burst? What is the equation between the pressure inside the tube and the point at which it ruptures?
So there are two kind of working with the tube. One is the direct impingement of flame onto the tube. So if you have a direct impingement, then around 80 to 90 degrees centigrade, the tube will rupture.
You mean the flames touching the tube?
Flames touching the tube. The other portion would be that if you have a rapid increase in pressure in the ambient temperature, if the relative to the pressure is higher at a lower temperature, and if the pressure is lower at a higher temperature, as the ambient temperature changes, you will find actually a weak spot on itself.
Sure.
And once it does that, it will create a rupture only at that direction and directly impinge your extinguishing agent directly onto the fire. Or it will be a very quick catch.
So is it safe to say that at the core of the function, you have a pneumatic mechanical actuation, which is nothing electronic, no electrical impulse happening anywhere. Whatever electronics we put in the response panel or everything, the read switch and everything, is on the outer periphery. At the core is a mechanical system which is foolproof.
It's totally standalone. It does not require any external assistance.
Correct. Yeah, so that was beautifully explained for the direct system. Now let's look at the indirect system where the discharge, you say, is from a different.
Yes, for an indirect system, it is the same thing as for the direct system. The tube is as close to proximity to the thing. And the ball valve is only maintaining the pressure on the head of the cylinder, which keeps the piston down which keeps the cylinder closed. So to closing this ball valve, whatever pressure we have left in the top of the valve is now keeping the cylinder closed. So once the tube is attached, it is pressurized, it is equalized to the pressure requirements of the system, the ball valve can be opened, and now as the HST is in close proximity to any fire, it ruptures. Once it ruptures, the pressure on the head of the valve is removed, and this in turn allows the piston to move out due to the propellant pressure inside the cylinder. This opens the cylinder valve, and now this mechanical action will allow this port to exit any extinguishing agent which is inside the cylinder, whether it is gas, foam, powder, whatever it is. And then it is taken through a series of pipe and nozzles into the vicinity of the fire, and the fire gets extinguished.
Sure. So that brings me to the other question that I'm asking on behalf of our customers or of our viewers, is that how do you decide between whether a direct system will go there or an indirect system will go there, apart from the basic construction or the basic constitution of the panel? Is agent also a deciding factor?
Yes. See, if you're looking at hidden fires in electrical panels, you're looking at agent that can have a good penetration power. So you will be looking at a gas-based system in that case. If you're looking at A-class fires and putting out fires in those classes, then you'll be totally favored into using something like a MAP 90 or ABC powder or ABC class firing powder.
Sure.
And then if you're specifically looking for B-class firefighting, then you'll be favoring a B-class agent or a foaming agent. So that would be one factor. The second factor which could dictate your choice of a direct or an indirect system would then be in terms of how many compartments you want to protect. And if you have limited numbers of large compartments, there are two things which are required over here. One, that the number of compartments that you can cover is limited. Second, is a large compartment. So the discharge that you require is going to be of a massive requirement, and you have to also maintain the fact that you discharge very quickly. If it's a slow discharge taking ages, it does not help. You need to kill the fire at its butt as quickly as possible. So you'll be using an indirect system there. For a direct system, it is very simple. You're looking at small compartments, you're looking at small quantity of gas, and you want to cover a numerous number of compartments. So there you go for a direct system.
So for a direct system, how do you manage the flow of powder, gas from the same kind of tube, or is it a different tube in both the scenarios?
When we're using, that's a nice question, Vishal. When we're using gas, we're using a 6 mm tube, okay, with enough 4 mm. For a gas, for a foam or a powder-based system, we are using 8 mm tube with an inner core of 5.3 mm. Okay.
So you give a little
more space for the agent to flow, give a little more flow, so you can have a quick discharge. So a managing over there.
Sure.
But the same kind of effectiveness which is available with the 6 mm is also available with 8 mm.
Sure. So before I come to the application side of the story around CQRS, let's spend 2 minutes talking about the electronics that you put around it in terms of the response panel and the read switch, because I see you have a provision for the electrical impulse to also travel from the ball valve so that your response panel can read it.
Yes. So you've seen that what is the importance of this integrated ball valve. So it means that if this is left closed, even with the system fully functional and fully commissioned, the commissioning is not completed till the time this ball valve is on. Okay. So we need to be totally sure at all times that this ball valve has never been left closed. And this is facilitated by the reed switch, which is again integrated. It's a proximity switch. It works like with a magnet. You can slightly turn it a little more around where the wire is attached to the valve. Okay. This is just a proximity switch. And the advantage with this proximity switch is that it does not impinge into the valve body again. It is just taking the signal or the magnetic position of the valve from afar. So this also helps in reducing any leakages. And especially, Vishal, now that we are going to foam and powder.
Yes.
We are also looking at the system being installed where transportation will be involved.
Yes.
So on the jerky, okay,
Vibrations.
the biggest advantages of these systems with lesser number of and now going to appear most essential.
So do you need a special tool to turn it on and off, or do you?
Yes, we have a multi-tool. The multi-tool allows you to open the valve and close it easily. So there's a multi-tool available. There are specialized tube cutters which are there. There are deburring tools which are there. All that assist into the specialized installation of CQRS are available.
Is that an Allen key to move this? Is that Allen key?
See, we introduce an Allen key into this thing. It's not a normal kind of screw which anybody can open and close.
Correct.
Allen keys are limitedly available.
Yes.
So this is available with only the service technicians that install the system. So nobody inadvertently can open or close the system. Further safety has been introduced.
So is the idea this, that while maintaining, while cleaning, nobody accidentally turns it off? That's the idea?
Yes.
That's the idea. Okay, lovely. So that's where we have the electronic the response panel coming around for CQRS. Now, having introduced direct, indirect, in both high pressure, low pressure, and in so many agents now bringing powder and foam as well into the kitty, are we clearly seeing the application of CQRS going far beyond just the electrical panels to include all sorts of enclosed spaces? Is that what we're saying?
Yes, we're looking at all sorts of enclosed spaces and open spaces. Where powder and foam are concerned, you can also use them in open spaces. Only gas-based systems require enclosures. Others can be allowed to work in open spaces. We are looking at, with foam, we are looking at automated CNC machines, most essentials, very expensive machines, molding machines, okay, and we are looking at any kind of tank protection which is going to be there, where you can have internal nozzles, and you have a fire on the surface of the tank. You have the nozzle impinging in foam inside and putting out the fire. It can be in both ways. It can be either direct or indirect system, whatever the requirements states. It's a larger tank, you might take an indirect system. It's a small tank. You can just put in a HST and achieve the same kind of protection.
What about moving vehicles, vehicle compartments, engine compartments?
Of course.
Wind turbines.
Wind turbines, electrical protection of engines,
Generator sets.
So there are a lot of applications. I think Vishal can keep on telling me application. I can keep on saying yes.
Look, the direction in which I'm trying to hint is that it's not. It started out as a hit product for electrical panels because that story everybody understood very well. But the application this is far more versatile. To be just restricted for one application is what the point that I'm trying to draw everybody's attention.
Vijay, what's the beauty of this thing is that if somebody has understood the system, I think somebody will come up tomorrow and say, can we use it or in this kind of application, which we might not have mentioned today. This is not an exhaustive list. There's so many possibilities now. We have opened up so many avenues of applications that you can use them in. Only thing you need to understand is when you're doing a gas-based system, you need a limited enclosed area or a volume. And in case of powder and foam, you can have the liberty of being an enclosed area or an open area, whichever it might be. But when we are giving you powder and foam, we have opened up so many new applications. Electrical panels is no more than limited.
Correct. So that reminds me of the next thing I wanted to ask, which is about preparing the thing for newer applications. That's on one side. Let's talk for a few minutes about the certification that we've got for this system, because for the normal person who's listening to us, many people feel that certification is yet another tick mark that they've achieved, but they don't really understand what value does it bring to the table for a customer when we say that the system is certified by LPCB under LPS 1666 standard. So can you throw some light on that side, brother?
Okay, so let's understand what is a standard. When we say a standard, we have actually laid out rules to a certain kind of application and installation. Okay, now these rules are because people have researched, a committee has researched as to how the system can be most efficient into a certain kind of application or a certain kind of enclosure or a certain kind of installation. That is one thing. Okay, so for example, I'll give you a very small analogy. That is, say if you want to say that my 2 kg cylinder is going to cover a 2 kg volume of protection into a 2 kg, 2 cubic meter of volume, then we have actually done that test and shown it that the gas is going to fill the whole compartment, is going to put out the fire in all the corners. Okay, and we have also indicated how far from the fire the tube has been laid. So the tube has been tested for as per what should be the maximum limit for the source of the fire. The product in itself needs to be tested in terms of the aging factor, the corrosion factors, the longevity of stay. All these are also tested. The tube has been tested for its aging effect also. We've tested it under extreme conditions that what has been stated is actually true or not.
Right.
And for anybody who's taking LPS 1666 or who's actually looking at any kind of certification, the most important thing is the peace of mind. As with a lot of people, they do not understand the intricacies required for a system. So there have been experts who have designed a standard, and they're experts who actually understand what those standards mean, and then they have verified the product. So I have a third party who has vouched for the system in itself, giving you a guarantee that this is what they're stating, this is what we have checked, and this is what they've achieved. So this is what the standard is all about.
So I think that is very important to draw as a point in front of the audience, because it's not that the company has developed the system, had some successes using the system successfully on electrical panels, and hence launched in the market. We have brutally tested this thing against fire multiple times, and there are specifications that these certifications lay out in terms of what is systems you will keep, how will you do snaking, how will you do the installation, how will you do the design, how will you maintain, how will you address the customer
how will you address the issues of customer, how will you do the maintenance, the management, the risk assessments, how will you branch the tubing, what lengths of tubings you're going to keep, what tools to use, how to install. All this has been pre-planned. It's not that it is done for a site, it is already ready. So whenever we go to a site, we see something, we get it designed, we deliver to you as a package. Now, not only that, we have gone beyond standards. Where standards are not available, we have also got a BSI test. So we have got the equipment in foam and powder to be tested by BSI. Now, when BSI has tested the thing, we have kept in mind the same kind of requirements of LPS 1666 and seen that they are also incorporated in the requirements of powder and gas, though a standard is not available. But we have again tested the product the same way, proven the functionality in the same way as we did for our commercial DLP. I call it commercial because it's a long time now we've been working with DLP. Now we have new technology.
DLP is the direct low pressure variant. So never forget the starters. You will have a lot of new people join the system. So what we will do, Pranam, now is we will pause for a while and again pull up a small video of you making the demonstration of the product and the system getting on real fire, and let them watch the product in action. And then we will, when we come back, I think it will be very good to hear from you if there are any questions that you have, and then we can have a small discussion around that before we close the show. So I will pull up a product demonstration video for you.
The video,
in just
please
a bit.
Focus on the direct and the indirect systems. To the AI Center. Welcome viewers to AI Center. We are ready with the demonstration of Ceasefire low pressure in-panel tube-based suppression system. Here we have fluoroketone fire extinguisher. This is pressurized with dry nitrogen. To the head of this extinguisher, we have a special valve with integrated ball valve. The position of the integrated ball valve is also monitored by a reed switch by this panel. I will tell you the functioning of this panel a little later. The HST is pressurized to 15 bar, which equalizes to the pressure within the cylinder. This is the underline adapter where we pressurize the HST. Once the HST has been pressurized to 15 bar, this valve is open and now the cylinder is commissioned. In the inside of the panel, we have HST flowing throughout the panel. This moves in an unobtrusively manner. This will allow the daily working and maintenance of the cylinder without HST coming in its way. HST comes out and then it ends at one end with another end of line adapter where we can connect a pressure gauge switch. The PGS monitors the pressure within the HST. The PGS also has a switching action which will send a signal to the monitoring panel. The monitoring panel will keep system health in notice, and this monitoring panel can be connected with 4 systems like this. The monitoring panel also has a non-potential output which will help you connect with fire alarm panel. And this module has a very intelligent battery charging system. It can also provide you power for your strobe siren. Now, for the purpose of the demonstration, the system is commissioned. We are going to put a fire at this point. We're going to let the fire grow. We will see how the HST and how the agent comes and falls onto the fire and how it's pressed within the cabinet. So let's start with the demonstration. For the purpose of the demonstration, we are pouring out a little amount of heptane with the A-class fuel material, and we will light it. And I will just step back and let you enjoy the demonstration. So as the tube ruptures, there will be a loud burst sound. Charge is complete. You can see the rupture in the tube. And there is no reignition. So that completes our demonstration of CQRS low pressure in-panel tube-based suppression system. First, we have just seen the functioning of the low pressure direct system. Let us look at the functioning of the low pressure indirect system. For an indirect system, the HST on the head of the cylinder is again pressurized with dry nitrogen, but this plays the role of keeping the valve closed. It will only detect the fire and open the valve. It does not discharge the extinguishing agent. The extinguishing agent is discharged through a separate steel line which passes into the enclosure and disperses it via nozzles. As in the case of the direct system, the indirect system also has an integrated ball valve whose position can be monitored using a reed switch. The valve lever itself is secured into place with an Allen key nut. So let's go ahead and look at the demonstration of this system. For this, we are going to light a fire inside the enclosure. The HST is going to rupture from the point where the flame touches the HST. The tube is going to depressurize, open the valve, and the agent is going to come out through these nozzles. The tube ruptures. By this method, singular enclosures of large volumes can be covered. Also, if we are going to use powder instead of gas, the indirect system usage is essential. Thank you so much for joining me for this demonstration.
So lovely video again. I think this again summarizes everything that we've spoken about, demonstrates in action. One thing that is already 40 minutes into the webinar, so we'll try to make it short now and wrap up quickly. But one important thing that I missed out asking Pranav is and drawing everybody's attention to, more importantly, is the fact that the design of it, it's not a product which is off the shelf. It's an engineered system. So while you understand and absorb everything that has been spoken about for your specific premises, what will go best and how the system will be configured, you have specialists, at the back end with the company who will be configuring and designing and suggesting you what system to install. I think that's a big advantage with what we offer.
Vishal, with the extensive, amount of testings and certifications, we have come to a point where we understand all kinds of systems. We know what limitations and to apply and why they are necessary. So our design team is fully equipped into understanding, to how to design any kind of a system. So worldwide, if anybody requires a system like this, they can approach us, and our design team will design adequate and efficient system for their requirement.
Sure. So maybe
one thing which Vishal quickly I want to
yes.
If you had seen, in our indirect system, we had little perforations in the body. So we have got this system, the direct low pressure system, verified for forced and free ventilation too.
Yes.
Okay, so that is possible with us. So what are we going to do next, Vishal?
I thought I will just, if you can quickly take up some questions that may have come up.
Sure. So viewers, if you can just put in your questions in the question and answer session.
Yeah, in the
Please
question.
do not put it in the chat.
Yes.
We find it very difficult to find it from there. But let's put it on the chat. Put it on the Q&A section.
Oh, this is a good request that is coming our way, which is to use Hindi as a language. The only reason we say English is because we are addressing a pan-India audience, and so that there is no comprehension issue, we stay there. But point noted. और हिंदी में हम कैसे कर सकते हैं इसको दोबारा जरूर कोशिश करेंगे और valid suggestions, sir. How do we do it? We will have to work out a way there. And what is the other? Maybe have these videos. So yes, absolutely. These videos, while we speak right now, are getting streamed live, on our Facebook handles, and they are going to stay permanently there. And the other thing is that even if you have some afterthoughts and some questions that come up later in your mind that you want to ask, you feel free to put your questions in our social media handles. We'll be very happy to get them answered for you from our experts, and that's how we plan to do it. We are already 45 minutes into the show, so I think we will wrap up now with no more questions coming.
Everybody from Ceasefire can approach us at CCSS portal and put in questions over there, your queries over there, even at response@ceasefire.in. Our technical team will support you in any queries you have. In CCSS portal, we have a section called FAQs, and you can look into those, and I believe we have answered so many questions. You might find your answers there directly. You might not even have to wait for our answers. Sure. So go into the FAQ section and look at answers over there.
Yeah, we've taken these questions.
You have any?
Yeah, we have taken these questions. And when I say Facebook, our website address is ceasefire.in, and all our social handles are connected to that. Ceasefire.in, simple address for you to reach out to. I think we have something. The temptation is to take as many questions as we can. Which is the best powder base? Which is best powder base and foam? And please confirm, can we use foam-based CQRS or electrical panels? Of course not. So, okay, we have these 3 questions which we'll take up, Pranav.
Okay, very quickly, the selection of your agent. If you have electricity, we will advise a clean agent in that respect, because if you see, the whole intention over here is not to harm the product,
Yes.
not to harm your electrical panel, and to reduce the turnaround time. So if you're using a clean agent, an electrical panel which is most essential, then I would suggest going for a gas-based system. Do not go in for a powder or a foam-based system, because this will actually bring down your downtime for your electrical panel. If a specific requirement only where a B-class fire is going to be there, and you want most efficient B-class firefighting capability, you can either use foam or powder. But then again, I would say contamination would be equal in both the systems. Okay, where MAF will give you only physical contamination, which can be filtered out. So the choice is yours.
Yeah. So then it says, can foam be used on electrical panels? Foam is,
of course not.
of course not. It's an agent brought into the picture to expand the horizon for CQRS and get more applications included where Class B risk is high. And certainly electrical panel is not the place where...
Imagine the small intricacies where, foam will enter and you will have to service each and every part. This is what we're trying to avoid with CQRS. We are trying to curtail the physical losses. So we are trying, हम चाह क्या रहे हैं, हम ये चाह रहे हैं कि जितना भी लॉस हो वो कम से कम हो, क्योंकि ये सिस्टम की टेस्ट आपके कंपोनेंट्स को हार्म नहीं करेगा. That is what we have to say.
Correct.
No harm to the components.
Correct. So very quickly, last question we're taking for the session today is, what will you advise for 4-wheelers, foam or any other from Ceasefire?
We are looking. We are in the process of understanding these systems much better. But if you were to come back to me and say, I can do efficient work with both foam and powder. So the choice is going to be on the user. If he says he wants foam, I will do it with foam. If he wants it with powder, I will do it with powder. So both are efficient. It only depends on the choice of the user. And if it's left to our discretion, then I would say for a B-class fire, I would most, be tempted to do foam, where I'm doing a little bit of cooling, plus I'm also doing, the blanketing. But here again, powder can also be very useful, because if foam was to flow off from the surface, it will give no blanketing effect at that point. So it all depends into our perception, into seeing what is the height intensity requirements of what we need in protection, and we'll make a choice of foam or powder. But both are available and both will work efficient.
Thank you so much, Pranav. And with that, I think we will close the session today. Thank you so much, everyone, for taking our time and joining us. Please do connect with us in these series that we do. And it is always lovely to connect. If there are any questions that you may have, like I said, these videos are going to be posted onto our Facebook, YouTube, and other channels. And you're most welcome to put in any question that you may have. We'll be very happy to answer. Thank you once again, everyone, and good day to all of you.
Good day and namaskar.